I'll click the lights. We'll get going here. All right. So practice test today. I'm gonna zoom in here. Okay. Obviously, it's over chapter 4 and a little bit of chapter 8 since we did that. The goal today is to kind of get us back in the swing of things of chapter 4. It's been a while since we've introed chapter 4. There's some vocab words that we need to talk about. I've kind of mixed them from section 4 or chapter 4 and chapter 8. They're just a select few words. Obviously, you can kind of tell some of the words I've skipped as you look through this. There's a couple of postulates we've skipped, a couple of theorems. Anything that had a major name to it, like SAS or SSS or ASA or AAS or HL theorem or Isosceles Triangle theorem. Anything that had a major name for a property, it's probably one of the main ones we need to know. But basic vocab words, they're probably on the test. I'm going to have about 6 terms here, and then you have a word bank to pick from. It'll be basically the same size. I'm not going to pick anything crazy. Some of the words you've seen quite a few times, like we've seen the word leg and base and congruent. Perpendicular, base angles, vertical angles. We've seen those words a lot, but some of the other ones that you may not have seen a lot is maybe the postulates, so you might want to think about how to read those. So let me go through these. What I'm going to do is I'm going to read off the definitions of some of these words, just so you know them, and then we'll get to this. So remember, isosceles triangle, by definition, 2 sides are equal. It's a triangle with 2 walls being congruent to each other. I know some people always think, oh, that means the base angles. That's one of the properties. That's actually this theorem. This theorem, the Isosceles Triangle theorem, which was one of our theorems we had in chapter 4, talked about that if you have 2 sides being equal on a triangle, then the angles across from them, the base angles across, are also equal. Okay. Vertex is the angle that is in between the 2 legs. It is opposite the base. That is a vertex angle. That is a specific angle of an isosceles triangle. It is the angle opposite the base, but it's in between the 2 legs of an isosceles triangle. Base angles are the angles that touch the base of an isosceles triangle. They are opposite the congruent sides. That's a key word here. The base angles are the angles across from the legs, across from the congruent sides. Okay? SAS. It's a postulate that we've had where it said, in a triangle where I think it's like 2 sides and an included angle. Included means to be in between. Of one triangle are congruent to the corresponding parts of another triangle, then the triangles are congruent. So again, 2 sides and the included angle. Okay, moving on. Let's move on to leg. Leg of an isosceles triangle with walls that are congruent. Okay. SSS. 3 sides. 3 sides are given. So 3 sides of one triangle are congruent to 3 sides of another triangle. Then the triangles are congruent. That's the SSS postulate. And again, notice I don't require that you know the theorem numbers or the postulate numbers. That's not something I require. Base. The base is the random third wall of an isosceles triangle. It is different than the 2 legs. It is random size. It is opposite the vertex. Maybe that's one of the key words that the book said. Okay, let me scroll down here. Okay, so 6 terms. So, okay, let's keep going here. ASA, it's where 2 angles and the included side of one triangle are congruent to the corresponding parts of another triangle. Then the triangles are equal. But 2 angles and the included side. That's the side in between them. Okay. Let's see. Congruent, equal in size, shape, and measure. You should probably get that one right. Exactly equal in size, shape, and measure. And then perpendicular is any geometric figure that intersect at perfect right angles.
Or it is exactly equal in size, shape, and measure.
It's an E, isn't it?
It's like a C from where I am.
Is that an E?
Oh, maybe it is an E.
Is it an E?
Well, the light's hitting
It looks really bad.
It looks like a C. Maybe it's an E.
Let me zoom. Hold on. I'm worried. Zoom. No. Zoom.
Oh,
It's an E. It's an E. Confirmed. It's an E. I didn't type it that bad. All right. No, it's an E. All right. But again, perpendicular. 2 geometric figures that intersect at right angles. Okay. Questions on the vocab terms. Okay, again, something very similar to that. Remember, some of the things I can add, like HL theorem, LL theorem. Those are some of the theorems we've had that actually had names. Pythagorean Theorem, that was a big one that we've talked about. Like little things that if they have a name, they probably could be a vocab term. I could even put sine, cosine, tangent in there. And what I would put for like sine would be, it's a relationship of an angle to the opposite wall and the hypotenuse. That would be the sine. Cosine is adjacent to hypotenuse. Tangent is opposite over adjacent, SOHCAHTOA, right? We talked about right triangles where they have a right angle in them. So just kind of keep that in mind. I'm going to just pick basic vocab terms. The ones I'm worried about right now are these. Okay, these are the ones that you just kind of have to read them. You have to go back in chapter 4, kind of read those postulates that we discussed so you kind of know. I think they're on section 4.43, I believe. 4.3, when those postulates all start. Okay, questions? Okay, let's move on to the next ones. Okay, next few here. All right. This question is based on section 4.1, where in the first section of chapter 4, it didn't just talk about triangles. It talked about any shape in general. But what they talked about is like, if you know that these pictures are actually congruent to each other. So like this picture is actually congruent to that one, where if you could rotate it, flip it, whatever, where they land right on top of each other, where every wall is like perfectly corresponding to each other. What I want is you to answer these questions here, these blanks. You can write your answers over here if you need to. That satisfies the condition. So like you're putting the letters in the right order. You're giving me the right size, like length. Like this one wants a length in so many centimeters. What angle's equal to this one from one picture to the other? So we'll do a couple of these. So like on this picture, angle or vertex B, what does it correspond to over there?
R.
R. That's what you put. You just put R. That's what you put for your answer. Because that's like those correspond to each other. On one picture they said B-L-A-C-K. B-L-A-C-K. Well, you have to give me the letters in order from the other picture. Now, again, it doesn't have to spell anything. I just picked these letters in that particular order. I could have went in any order I wanted. So when you go to the other picture, don't think that you have to spell a certain word. It's just you have to give me the letters for letter. So what matched B again? R. That better be your first letter. And then what matches L?
O.
O. That better be your second letter. And then you keep going. You got to give me, 5 letters in order. So R, O, and then keep going from there. I think you get a nice sense for how that works. And they have to be in order because it has to spin like clockwise or counterclockwise. Angle, the measure of angle E. So when you find angle E, what does that correspond to on the other picture? C. So you go measure of angle C. Okay, that's what you do. Okay. So just be careful. This one wants so many centimeters. It doesn't want like a side. It wants so many centimeters. This one wants what angle you're equal to. So keep that in mind. Okay. So letter for letter, symbol for symbol. Try to keep it the same. So if they use like little angle symbols and 3 letters, you have to use an angle symbol and 3 letters. You're comparing one picture to the other. That's something very similar to test day. I'll give you 2 pictures. They're supposed to be congruent to each other. You have to kind of figure it out. Okay, how they overlap. And again, I'm just going to pick a picture from your book. So something that you've probably seen before. Okay, questions. Perfect. It's just to get a sense for how things match. It's corresponding parts. That was section 4.1. This would now be 4.3. 4.2 is all about angles and stuff of triangles. Like the basic properties where triangles have to add up to 180 and all that good stuff again. But this section, this is 4.3, talked about if you're looking at different problems. These are 3 individual problems. I numbered them, 1, 2, and 3. Okay. What you have to do is look at this picture and tell me, are the 2 triangles congruent? Okay. So are these triangles equal? And if they are, so you have to put yes or no. If they are, if it's a yes, you have to tell me which one of these postulates explain it. Okay, you can fill in markers, like you can fill in markers on the reflexive wall. You can fill in markers if they have vertical angles. You can fill in markers, let's see. You can do base angles if it's isosceles, but I don't think they have isosceles pictures here. You can potentially do that. All right, but anyways, so I'll do the first one for you. So the first one here, they definitely have these angles. Those are the same angles. I know that picture looked terrible. It was right out of your book. So those angles are the same. They have these walls. And is there anything else that they share?
Reflexive wall.
Reflexive wall. Okay, so now I have 3 markers. do the 3 markers spell one of these acronyms?
SAS.
Yeah, say it.
SAS.
Yeah, so this is a yes. These 2 triangles are equal to each other because the acronym it's spelled is side, angle, side. SAS. Okay, so that's a yes. You can only use the 3. Now, technically, we do have a 4th, angle, angle, side, but you could prove it using the other ones as well. You can't use any of the right triangle ones like HL, LL, HA, or LA. You can't use any of those because we don't have right triangles here. They don't give us that. So it's got to be one of the main 3 or 4. I give you 4. Okay, so that's the first one. Some of them might be no's, some of them might be yeses. So just be careful of that. Okay, do you guys get what you're doing on each one of those? Each one you need a yes or no. If it's a no, just move to the next one. Okay, be careful. There is a no in there somewhere. Okay, questions. Anyone have any questions earlier? Okay. All right, let's get rid of this, but that's what you have to do on these. Okay, so it'll be something very similar. I'll give you pictures from the book, and you have to tell me yes or no. Basically what I did is I just pulled the pictures that were from proofs that you had to do, and they all had the markers on them, and it was basically, can you figure out are they equal or not, by just looking at the pictures. They have to have 3 markers, and it has to spell the correct acronym, not the inappropriate one. Keep that in mind. Okay, let's move on. It's kind of rapidly approaching. All right, this is the one we're going to spend the most time on today. It's a proof. Okay, we have to prove that these triangles are, or actually we have to prove that certain angles are equal in this case. This proof, I would assume 4 lines, 5 lines, somewhere in that range. That's usually what our proofs always take, 3 to 4 or 5 lines. Why I'm thinking 4 or 5, because we're not just going to prove that the triangles are equal. Okay, we're not going to just prove that these triangles are equal. We have to go one more step. We have to use that CPCTC line, the extra step that says certain angles are equal. Okay. Certain cases, there are some easy ways that some people just don't think about this. Like there's some obvious things that you could potentially tell. But we're going to go through the proof. It should take about 4 or 5 lines. That's what I'm expecting. Okay. All right. So if you need to, we're going to do the full column proof here on this one. I think on test day I will allow for the flow chart where you just do circles and you just start arrows. So you don't need to give me property names. I'll kind of give you a hint, but I'm going to do all the steps so in case you're wanting to know. Some people just need to see this. All right, let's start. How do you start your proof? Given. You got to start with all the givens. We actually were given quite a bit. We're given all of this stuff. Do not put this as your given. That is not your given. That's what you're trying to get to in the last step. Okay, so the first line you should be writing all the stuff we're given. We're given that PR, that line, bisects angle QPS. If this line is bisecting an angle, that means the angle's cut into 2 parts. Okay, you can probably see that, QPS. QPS is this angle, by the way. Q to PS is this angle. That angle's been split. Okay, we'll come back to that in a minute. The other thing that we're given that PQ, the line, is congruent to PS, the line. Okay. And these are all our givens. Let's write that down. Sorry, I'm going a little fast. Okay, so PR bisects QPS. And PQ is equal to PS. All right. Now, line 2 and 3, they could be potentially switched. We'll see this here in a minute. Is there anything else that you want to start with on maybe line number 2? Anything that may be obvious?
PR equals PR.
Yeah, you can do the reflexive wall, all right? The stick in the middle. This stick is equal on both pictures, the top triangle and the bottom triangle. So that could be your line 2 or line 3. I usually reserve for line 2. But PR, that stick is equal to itself PR. And the reason I even said it earlier is the reflexive wall, right? The reflexive property is something equal to itself. Okay, so so that would be something obvious. Now, technically, the only marker I have technically on the picture right there is that one. Even though I was supposed to fill in from line number 1, I was supposed to fill in that certain walls are equal. I forgot to fill that in. PQ and PS. All right. So, I wrote the double markers so we're not getting all confused. There we go. All right, I forgot to put that in line number 1. I forgot to fill in those 2 markers. P, Q, and PS were the same. They explicitly said circumwalls are equal. All right, line number 3, we probably should talk about that whole bisector thing, the thing I was giving you a hint on earlier. So line number 3. So if this line PR bisects this angle, what can you tell me about the two angles then?
Okay.
Yeah, so this angle here is equal to the bottom angle. I don't know how many marks you want to put. I'm just going to put single markers. So that angle there is equal to that angle. Okay? They're the same angle, so I'm going to write those down. And the reason why is because of bisecting. That when this PR bisected that angle is cut into two equal pieces, and you just have to figure out which angles those were. So that's angle QPR is equal to angle SPR. And those are the markers I made, which the whole reason is the definition of an angle bisector, or you can just write definition of bisector. I don't care what you put. Okay. When you bisect something, they're equal parts. It's like midpoint. Midpoint means the same thing. Two walls are equal. So I think we have enough marks to prove that the triangles are equal now. So I think, yeah, because we have 3 marks per picture. So the two triangles should be equal to each other now. So let's go to line number 4. This is not my last line because we have to go one more step. But why are the triangles equal? What acronym does it spell?
SAS.
Yeah. Side, that's a side marker. This is an angle marker, and that's a side marker. And that is one of our acronyms. Remember, one of the acronyms that you're trying to fall back on, these are the 4 you can use. These are the 4 we've had since chapter 4. Okay, these aren't right triangles or anything like that, so you can't use, HL or LL or anything like that. But these are the 4. Obviously, the one that does spell is that one. Side markers, angle markers, and side markers per picture. They all have 3. That's what you have to get to. So I can actually write that these triangles are equal. So the top triangle is what? PQR. PQR, that top triangle is equal to the bottom triangle. PSR. PSR, there we go. And the whole reason is side angle side. Postulates. Now, I can go with one more line. What's the last line of my proof? What should it be?
Angle Q is equal to S.
Yeah, what you're trying to prove. This should be the last line. You should not get that wrong. That's what we're trying to prove. So we're trying to prove that dot 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 angle Q is equal to angle S. And the whole reason, CP, CTC. If the corresponding parts of congruent triangles are congruent. That's the whole idea. If the triangles are congruent, then the parts about them are all the same, including the remaining walls, the remaining angles, everything. So that's why Q and S had to be the same angle. They look the same, but you had to prove it. Okay, questions. And again, test day, I'll kind of give you a hint, like if I want a flow chart or if I want a full-on proof. At least something easy. I'm not going to pick something that's so out there, like there's no way you're going to figure it out. I would never do that. I'll just put something on there that you have enough information, you get to one of the, one of these acronyms, really simple, and then you can go to whatever you're trying to prove. Maybe you're just trying to prove the triangles are equal, so it's really short, 3 to 4 lines. Okay, questions. So if yours says on the test data, it says show all steps and justify, that means you have to give me the properties. If it says choose any method, you can do paragraph proof, you can do flow chart, where you do little bubbles with no reasons. So some people like that. But you have to get to a point where you do actually prove that they are the same. Okay, questions. Good. Last question of the day. So I want to do about half your practice test today, and we'll do the other half on Monday. I added the practice test to the website. I did that. I made sure it was on there this morning, so if you need to re-download, maybe you lost it over the weekend, you can do that. I even put them as pictures in case like it's not showing up for you. You can always download the picture instead and just print the picture. So I try to cover my bases there. Okay, last question of the day. This one's based on isosceles. So this is really one of the last few sections of chapter 4 that we covered. This was supposed to be isosceles or equilateral. Well, if you look at the picture, is it equilateral?
No.
No. because two walls are different, right? There's a 16 and 18, not equilateral. But it could be isosceles. So, if it's isosceles, how do you know?
Two angles are equal.
Yeah, two angles are equal. That was one of our theorems we had. It was actually the converse of the isosceles triangle theorem. The isosceles triangle theorem says if two walls are equal, the base angles are equal. The converse of it said if you start with base angles, then the walls across from them are the same. These are the walls across, so these are the walls that are equal. So set those two equal to each other and solve. They're not, don't add them all up and set equal to 180, that's silly, that's what you do for angles. For walls, since I have two angles matched, these walls are the same, set them equal to each other. Solve for x. It could be a whole number for all I care. But you have to find x. On your picture on the test, it could be find x, find y, it could find w. You could have just a bunch of different things on there, but it'll be something straightforward enough. You have to do some math. It may require a calculator, and they could be a decimal. So don't fear if it is. I don't think yours is, but it could be on the test day. Questions? How to do that? So set those equal to solve, because it is isosceles. All right, that's it for today. Now, if you keep looking, if you look further past that, the rest of the test is from chapter 8, simplifying radicals, you know, how you break them down, show what the numbers are, how you kick numbers out. The next one is, you know, lag, altitude theorem. I'll probably have those formulas on the board on test day. The next one is Pythagorean Theorem. That will be on the board on test day. The next one after that is the Pythagorean Theorem, but then the ones in the back are like trig functions. It's the very, very back page. Those are the ones on the very, very back, other than the Pythagorean Theorem stuff. You will definitely need a calculator. There's no way you can be able to handle that last page, the back, unless you have a calculator and you know how to use it. Remember, on test day, I will not tell you how to use a calculator, so keep that in mind. That's an inappropriate question for a test day. All right, that's it. That's it for today. I'll stop the camera here and you guys can have the rest of the time to work.